Hello everyone. In this lecture, I will discuss a new course which is graph theory. So basically, in this lecture, I will discuss some introduction of a graph theory. From the next lecture, we will discuss the theory of graph. So basically, graph theory is the most important area of modern discrete mathematics, like many fundamental branches of pure and applied mathematics. So graph theory is basically originated by the Swiss mathematician Leonard Euler. Okay, so many real life we can see the application of a graph theory in the real life applications like Google Maps. How is working Google Maps? If we want to find the shortest distance between two destinations, so these are the applications of a graph. Okay, so graph theories have various areas, applications in various areas is like computer science, chemical graph theory, electrical engineering. So here I want to discuss the graph. So how can we make a graph? So for making the graph, first of all, we have a discrete structure which is consists set of objects. Okay, so these objects is called as a vertices, and the relation between these objects is called an edge. Okay, so mathematically we can say that a graph GV equal to V comma E is an ordered pair of V, G and EG, where VG is non-empty set of vertices and EG is the two subsets of vertices which VG called edges. So basically we can see that let us suppose that we have a graph. These are the discrete structure. Okay, like these are the discrete points, and we want to join these points by an edge. So this is called a graph. So how can we say this graph in a real life? So let us suppose that this is a person, this is also in another person, these are the persons. Okay, p1, p2 persons, p3 persons, p4 persons and p5 person. So p1 is sharing the information to p2, and p2 is also sharing the information to p1. So there is a relation between them. Okay, same for p3 to p2, same for p2 to p5 and p4 to p1. Okay, so they are sharing information to each other, like p4 is sharing to p1, p1 is sharing to p4, p1 is also sharing to p2, p2 is also sharing to p1. So this is an a we have, first of all we have a discrete structure like a persons, and now we are connecting these persons with the help of a relation is like they are sharing the information. So this is in a basically graph. Okay, so this mathematically definition how can representing, let us suppose that I will do the labeling these vertices 1 2 3 4. Now I will make a set E, which is here is written two subset. Two subset is like that 1 2 comma 1 3 comma 1 5 comma uh, 2 3. So means these are the vertices 1 2 3 4. Okay, now 1 2 1 2 means there is an edge between 1 2. 1 3 means there is an edge 1 3. 1 5, here is also 5, so 1 5. So 1 5, there is an edge between 1 and 5. Okay, so next 2 3, if we will write here 3 4, so this is also an edge 3 4. So basically what is saying in definition, a graph G equal to V is an ordered pair where V of G means set of vertices and E of G means set of edges, where V is a non-empty set of vertices and E of G is the two subsets. Two subsets is like that 1 2 1 3 1 5 2 3 3 4 is called the edges. Okay, so this is an example of in a graph. So next definition is about a simple graph. So a graph which contains neither self loops or parallel edges is called a simple graph is like that. We will define an example. So this is in a graph, this is in a simple graph, means in this graph there will be no self loop and there is no parallel edges. Like parallel edges means we have in a, these are the parallel edges. So here in this graph G there is no parallel edges. Self loop means a vertex which is connected to itself. So this is an only self loop. So a graph which have neither self loop nor parallel edges is called a simple graph. Multigraph, a graph which contains parallel edges but not self loop. Like so this is a multi-graph, a graph which contains parallel edges. So here these edges are parallel edges but no self loop. So that graph is called a multi-graph. Next definitions is related to adjacent edges and adjacent vertices. So two edges EI and EJ are said to be adjacent if they have a vertex in common. Let us suppose that this is also an edge V1 V2 and this is also an edge V3. So two edges E1 and E2. Two edges E1 and 2 are said to be adjacent if they have a vertex in common. So this is a vertex which is common. Okay. So two vertices VA and VJ are said to be adjacent if and only if they have an edge in between VA and VJ. So these are two vertices V1 and V2. When we will say these two vertices are adjacent means there exists an edge between them. Okay, so here we can say that two vertices are adjacent. Here we can say that two edges are adjacent when they are sharing a one edge, one vertex is common. Okay. Next is related to incident between edges and vertices. So an edge is said to be incident with vertices at join or vice versa. Okay. So next, degree of a vertex. So degree of vertex is the number of edges incident to the vertex. Like basically incidence is a property which is related which is between edges and vertices. I can say that this edge is incident on vertex V. This is vertex V and this is an edge E1. So E1 is incident on V. Okay. So degree of a vertex is the number of edges incident to the vertex. So we are defining a graph here. We are defining a graph. These are the vertices. Okay. So V1, V2, V3, V4, V5. Okay. So here we can say that V1, this vertex V1 have two edges are incident. So degree of V1 is D. Degree is denoted by basically D. So degree of V1 is 2. Degree of V2, 3 edges are incident on V2. So degree of V2 is 3. And degree of V3 is 1. 1 edge is incident on V3. V4, degree of V4 is 1. Degree of V5 is 1. So degree of a vertex is the number of edges incident to the vertex. Okay. So in the next lecture I will discuss some more basic definition of a graph theory. Okay, thanks.